Alright everyone, I'm going to show you how to make a screen recording, and I'm going to show you how to make this video lesson in an app called Doceri. You can use it in anything you want. Doceri has its own sort of screencast filming feature, that's why I'm using it. You can use any app you want, including Notability, because your iPhones and iPads can automatically screencast and screen record. If you don't know how to do that, I'm going to show you right now. I'm going to tap on Settings, and then in the Control Center, you would tap Control Center, and then you would tap Customize Controls. And then right now I have my screen recording in my little hotspot, but if it's not, you'll find it down here, Screen Recording, then you'll just tap the plus sign, and all of a sudden Screen Recording is a part of your Control Center. So then all you have to do to screen record is drag down your Control Center, and it's this little button right here that's flashing, and you'll be able to screen record. Okay, I'm going to take you through some of me building a video lesson in Doceri, and then I can show you what the final product looks like. So Doceri is an app that is available to you through self-service. My Doceri app is the third one from the right, so it's the little finger pointing to touch a button, so I'm going to open that up. I've already started one called Antibiotic Resistance. These are all the notes that I've done, different folders for different things. These are how I do all my video notes. So, Antibiotic Resistance. Doceri is really nice because you can sort of like move through it at a much faster pace after you write it. So I can just put up Antibiotic Resistance. You don't have to watch me write it. You're watching me build it, so that's a little different. I'm going to show you some of the tools that Doceri has. Again, I'm making this really quickly. You'll want yours a little neater than this. Your Notability with a screencast might work really well. So a couple of the features of Doceri. You've got an eraser here. If you don't like the way that E turned out, you can erase it. You can two-finger pinch away to zoom in on an area, so that if I want my lettering to look a little nicer, I can take my time, and the letters are really big here, but then when you actually see it, the letters are back to a normal size, so the letters look a little better. My handwriting isn't great, so my letters always kind of look a little crummy. You can draw simple shapes, point arrows to different things that are important, box, whatever. So play around with that, see what you find. If you tap this, the curly cued back arrow, so as I move across here, the next thing I would touch moving in that order is a forward arrow that would redo anything I undid. The next arrow is undo anything you did, so I'm just tapping that to get rid of everything. Here is a really nice feature. You don't have to draw everything under the moon that you want to include. So what you can do is you can go to Chrome, and I've already found an image that I like. I think this image is interesting and shows examples of how antibiotic resistance spreads. So I'm going to tap and hold, and a bunch of options pop up, and I'm going to tap Save Image. The great thing about Doceri is that it has access to your photos. So when I open up Doceri, I click that Place Image, and from iPhoto Library, and all of a sudden, my recent photos are there. I'm not going to use the one I just found. I found another one that's good for a front page. It sort of shows this gangster member of the antibiotic resistance handing over his DNA to this unsuspecting non-antibiotic resistant bacteria. And it's a little cartoon that sort of gets at what we are trying to articulate in this. So I put that in there, and that's my front page. Obviously, I'm doing this in like 10 minutes. You'll have another week and a half after watching this video to do this. You've hopefully already gotten all of your information, and so I anticipate yours looking a little better than just writing antibiotic resistance across the top and having this picture here. But this is at least a start to show you. Here's what I'm going to do next. I'm going to show how antibiotics become resistant, and I have an image. Here that shows how antibiotic resistance spreads. So I'm going to try and have it fill the page as best as possible. But then what I'm going to do is I'm going to change the size of my white to be as large as possible. And I'm going to erase everything except that initial bacteria. Because if I just give you that image all at once, it's too much information. And so I'm going to give you sort of information, one piece of information at a time. There are 3 different ways bacteria can exchange their DNA. One is conjugation. One is transformation, and so I don't like the way that's turning out, so I'm going to hit my back button to undo those, and I'm going to shrink my eraser so that all you can see is just conjugation really clearly, then all you can see is transformation really clearly, and then all you can see is transduction really clearly. And then I would take you through it one step at a time, and I would remember to note that if it's red, it's the resistant bacteria. So we're starting off with a resistant bacteria and showing how it spreads. It's going to spread to a blue non-resistant bacteria. It can spread with viruses. That will be our transduction. It can spread with plasmids or transposons, and that will be with conjugation and transmutation. And so first I would take everyone through conjugation. And you can see that this is a fine lesson that I am in fact not having to draw much for because my art skills are not great. And so here I'm going to do one at a time, and I'm going to show that transposons can come from the bacterial DNA or from a plasmid. And then I'll highlight and I'll say this is the bacterial DNA, this is a plasmid. In each of these cases, because I've looked ahead and know what's coming, this blue is the bacterial resistant DNA. So here it is in the actual DNA of the bacteria, and here it is in the plasmid. And you can just remind them again that a plasmid is just a loop of DNA that's floating freely in the bacteria. So here's our drug-resistant bacteria. Both its plasmid and its own DNA are resistant to the drug. And so then I'll show it like this. These plasmids have now, this plasmid here and this plasmid here, have now pinched off to be ready to send out through bacterial conjugation. Bacterial conjugation is when bacteria link up and then exchange DNA with each other. So here we are. Bacteria connect temporarily. DNA from transposons or plasmids can be passed from one bacterium to another. And now I'll show that transfer. So here is our bacterial resistant plasmid. Here's our connection through pili and fimbriae between the two bacteria. Remember, the light blue is the non-drug resistant bacterium, and so it is being passed drug resistant DNA. That transposon is then incorporated into the DNA, first as a plasmid inside this new bacteria, but then it gets incorporated into the actual DNA strand of the bacteria, and all of a sudden it becomes a fully fledged antibiotic resistant bacteria. Okay. So that is part 1. That is if you're just using the screencast. But as I said, Doceri has a really great option where now there's a record button in the upper left-hand corner. And if I tap record, here's what I would do. I would start back at the beginning. And now that I've pre-written and done all of my different pen strokes, I can just tap through using, there should be 4 arrow buttons along the bottom. The inner 2 allow you to move 1 pen stroke at a time, so forward, backward, forward, backward. The next one to the right jumps you to the very end of the slide, and the one all the way to the left jumps you to the very beginning of the slide. So what I'm going to do is I'm going to tap start recording, and I'm going to say, all right, everyone, today I'm going to teach you a little bit about antibiotic resistance. antibiotic resistance. And you can also drag this as you see fit. So I just tapped my finger on it and I drug it across. Okay. And so this is a comic illustration of what happens with antibacterial resistance. This is just one type of antibacterial resistance transfer. This looks a lot to me like conjugation. It is one bacteria giving its DNA to another bacteria. And so then I would move on and I would say, so I'm going to teach you about 3 ways antibiotic resistance spreads between bacteria. The first is conjugation, the next is transformation, and the third is transduction. And I'm going to take you through conjugation first. So conjugation is when transposons come from the bacterial DNA or from the plasmid and get transferred to another bacteria. And so then I would get, if you tap the top image, it brings up this arrow. If you tap the bottom image, it does either your eraser or your pen stroke or anything. But if you tap this top image, it shows you these, the arrow. And so then I would say, here is a plasmid. This plasmid contains this blue strip of DNA. This blue strip of DNA is not actually blue in real life, but it is highlighting that this is the antibiotic resistant part of the DNA. And the DNA that is in the actual bacterial genome itself also has a segment that is antibiotic resistant right there. Before bacterial conjugation, the drug-resistant form of this gene was copied and moved into a plasmid along with other plasmids that were already floating freely that contained the antibiotic-resistant gene. Next, what happens is bacteria connect temporarily from the transposons or plasmids and can be passed from one bacterium to another. So they connect via pili and fimbriae, this little bridge right here. And one of those antibiotic-resistant plasmids, now that it is being exchanged, is sent over to this non-drug-resistant bacteria. Remember, this is a non-resistant because it is blue. And once that moves across, the DNA to become drug-resistant becomes available. And so all of a sudden, this transposon that was sent across that bridge now becomes incorporated into the bacterial DNA right here. So first it's just floating freely, and then eventually it becomes incorporated into the bacterial DNA, and that bacteria becomes antibiotic resistant. So then I would simply stop the recording. It will automatically save it, and then we'll ask what you want to do with it. You want to drag it to YouTube. I'm going to call this Antibiotic Resistance Demo Lesson. The tags will be the exact same thing. And then I will send it off. You need your own YouTube channel in order to be able to do this. I have my own YouTube channel, so this will automatically link to my YouTube channel. If you don't want to do that, you can always just send that recording to me in an email. That would probably be the best bet because I think it might be too large to just upload directly to Neo. Yeah, excuse me. And this option, yeah, it's just more of the same. So I would say your best bet is to go YouTube and then share the YouTube link with me. If you do not have your own YouTube channel, it takes 3 minutes to create one, and then you can upload it to there. You'll get an email from the YouTube channel as soon as your video is done. And just to give you an idea, here's what people will see when they watch your video. They won't see the top part of the screen up here. They will only see the bottom part that we are wanting them to see. So if I look at my recordings, antibiotic resistance, and we play it, so it's moving very slowly. Start recording, and I'm going to say, all right, everyone, today I'm going to teach you a little bit about antibiotic resistance. So we can't see antibiotic. But take my word for it, all they'll see is what's happening in this bottom section down here. They will not see what happens in the top section up here. So none of this will be available to them. They'll only see this main image like you've seen me draw many times. All right.